Okay, this is an introduction to the Cart and Strings Lab. Now let's talk about the purpose of the lab first. Okay, what you're going to be doing is you're going to be looking at a train of objects, which is like an amusement park parking train, shuttle train, that are connected together. And they're connected together with brackets. And what you're going to do is you're going to apply Newton's second law, and you're going to discover the relationships between the individual tension in each of the strings or brackets between the carts and the quantity, the mass of the train that's being pulled. Okay? So let me explain what's happening here. The owners of an amusement park have purchased some really powerful golf carts and passenger carts, and they're going to move their guests across the parking lot. But they need to purchase these brackets, which are going to be placed between the carts separately, and they need to know how strong the brackets need to be, okay, that hold the carts together. So the train will work, the train will be held together, but at the same time, the brackets, the most efficient combination of the brackets for each train would be, say, the least expensive option. Okay, so they've hired your engineering team to help them. Okay, so now I'm going to give you a group of specs for your golf carts and passenger carts, as well as a price, and you can find that in the little quiz tab that goes with this lab. Okay, and so go to that, open that up, and it will give you the specifications for that, and I'll show you that in a minute. Okay, take the information from that quiz and copy that information onto your worksheet, and then we'll start the lab. One thing you should consider doing at this point is basically making a paper copy of the lab, making a paper copy of the lab worksheet so you can use that to write on, okay, as we go through the lab. Okay, so when you go to the little quiz tab and you get the information about the force on the golf carts and so forth, and the brackets list and the cost, you're going to put that into the table in the middle of the first page. And that information is going to go in this little part of the table here, and the information here, and the information here. So these are the parts of this table in the middle of page 1 that you're going to fill out with the information from the little quiz tab. Okay? The information on the quantity of the brackets, so the assessment or the result of this investigation is going to be determining the quantity of the brackets you need and the total cost of the brackets, so that you know how much you can tell the amusement park company what the total cost of the brackets are. Okay, and that's in red. So the stuff in red here, you're going to do later. You're going to do that at the very end. So don't worry about that right now. This is going to come up at the end. What you need to fill out now is the information in the black from the little quiz attachment that goes with this lab. Okay. So let's talk about how this works for a little bit and try to explain it before you get into the lab. So because we're virtual, we don't have this, but if we did, we could have a display in the room, and it would have a chain of boxes, friction boxes, and it would have little spring scales between them. Spring scales are those little weight scales that you can use, you can hang, and you basically they're very simple. They're basically, you hang a weight on them, and they expand or contract, and they give you the weight. Okay. So I've drawn a picture of the display, and now I'm going to talk about this for a minute. And then you need to do the same thing in your lab. You need to make a picture and then write down what you think about this, okay? So basically how this is set up is we've got a whole group of boxes, 1, 2, 3, 4, 5 boxes. These represent the carts in the train at the amusement park. The red boxes will be the scales, okay? These will be the little pull scales, okay? And there'll be one where your hand is pulling, and there'll be one between each of the carts. And these are in red, okay? These represent the brackets or the couplings between the carts, okay? So basically, if you set this up so that in each one of these boxes, you know, the black boxes will have some mass, right? Each one of these is going to have some mass. So for example, this would be mass 5 and mass 4 and so forth, right? I'm not going to label, well, maybe I will label all of these because I'm doing it now. Anyway, these each will have some mass. So when you pull these, what would you expect to find if you pull these across, say, a level surface with your hand here, and you looked at each one of these scales? What would you expect to see in each one of these scales? Okay, what would you notice about the readings of the scales? And one thing you might think about is, and I'll give you a little bit of a tip here so you can think about it ahead of time, and that's that if you think about each one of these scales right here, they're going to measure the amount of weight being pulled by the cart, by the cars and the scales behind them. Okay, so this one is going to be pulling this entire train. The scale here is going to be measuring the weight that's pulled in carts 2, 3, 4, and 5. The scale here is going to measure the weight pulled in 3, 4, and 5. The scale here is going to measure the mass of the weight pulled in 4 and 5. And then the last one's only going to measure the last cart. So you can see what might you say based on that here? Could you say something about the amount of force that you'd need to apply, or you would see at each one of these scales, depending on the position of the scale in the train? So what you want to do is write down what you think you would see right here. Okay, and think about that a little bit before you go into the lab. Okay, because this is the basis for how you want to think about solving this problem in the lab. Okay, the next part of this is that, so what I have here, this is on page 2. This is on the top of page 2. And I've labeled some of this ahead of time because I want you to have a sort of a system, and I wanted to help you set up a system for how you would do this work. Okay, so basically here's the golf cart train at the amusement park, and here's the guy driving the golf cart at the front of it, and he's pulling all the passengers in all these carts. So each one of these carts is, and they're all connected with a bracket. And the bracket, the bracket will have some tension on it, okay? And that tension will be a function of how much mass is behind that bracket, okay? So I've labeled the tension in the brackets T1, T2, T3, T4, and T5, okay? T1 is at the back and T5 is at the front. Also, each cart will have a certain mass, and we provided you that mass. Okay, the mass we provided you for each cart is right here. Okay, so we provided that. Okay, so you know the mass for each of these carts. Okay, we've also provided you the maximum pulling force of the golf cart. So we've also told you how much pulling force the golf cart can exert on the train. Okay, remember this lab is basically built around, so what your objective in then is to find out what the tension is at each one of these couplings, and then use that to determine the appropriate bracket to buy. Okay, and then select the bracket, the most appropriate bracket to buy. Notice, get the cost for that bracket, and then add the cost together so that you can get the most inexpensive set of brackets that you would need in order to basically run this train. At the end of the day, you're going to need 5 brackets. Okay, T1, T2, so forth. Okay. Okay. Remember, this is a lab that utilizes Newton's second law. F net equals ma. Okay. Okay, so we've given you m. That's right, and you can calculate the acceleration of this train, and you're going to see that in a minute. And then you know the strength of the brackets, and you can find that. Okay, we're giving you that information, so you can use that to do the rest of the lab. Okay, so remember, this lab is going to utilize mainly Newton's second law, F net equals ma. Okay, so get started in the lab. I'm going to help you as you go, and give you tips as you go, and try to get you to the correct answer. And as the period goes on, and when you get to the end, show me your answers, and then from there we'll talk about we can talk about why. Okay.